everyone, welcome to Pi Academy. Today we're going to be doing the 2025 AMC10A Problem 14. So 6 chairs are arranged around a round table. 2 students and 2 teachers randomly select 4 of the chairs to sit in. What is the probability that the 2 students will sit in 2 adjacent chairs and the 2 teachers will also sit in 2 adjacent chairs? Well, let's see. Something special about this question is it says they are arranged around a round table. What's special about a round table? Well, in a round table, you can rotate the seats and rotate the seating. So the key idea here is, say we have 6 seats. 1, 2, 3, 4, 5, 6. We have to put one student or one teacher down to anchor the table. So let's have S1 be student 1, S2 be student 2, T1 be teacher 1, and T2 be teacher 2. So let's just put S1 right here to anchor the table down. It doesn't really matter that we put S1 here because S1 being here versus there, it all doesn't matter. Now that we've anchored down the round table, now it matters that either someone's to the right of S1 or someone's to the left. Now the order does matter. So that's the key part to doing this problem. So now we want the total ways that we can sit everyone down. So the total ways we can have S2, there are 5 choices. 1, 2, 3, 4, 5. So we have 5 choices for S2. And likewise, once S2 sits down, there are 4 choices left for T1 and T2. Once T1 sits down, there are 3 choices left for T2. So the total number of ways we can sit them down is 60 because we multiplied them. But now we want to find how many ways are there that the 2 students will sit next to each other and the 2 teachers will also sit next to each other. Well, if we want student 1 and student 2 to sit together, there are 2 choices for where S2 can sit, either to the left or to the right of student 1. So there are 2 choices. Say let's sit S2 right here. Now we want to find how many ways S1 and S2 can sit together. Well, this is kind of tricky, but one way we can think about this is let's make sure T1 and T2 always sit together. So let's consider T1 and T2 as a big block. So we can either sit the block here, here, or here in order for them to be next to each other. So there are 3 ways. So T1 and T2, there are 3 ways. But notice we can also change the order. It can be T1, T2, or it could be T2, T1. So we have to multiply this by 2. So there are 6 choices here. So let's take these 2 and we multiply them. So there are 12 choices or 12 ways we can seat them. So S1 and S2 sit together and T1 and T2 sit together. So if we take 12 ways that satisfy our conditions over the total number of ways, which is 60, we get 1/5. So 1/5 of the time the students sit together and the teachers sit together too. So that gives us answer choice B.